Welcome students to geometry class. We're studying chapter 6 trigonometry part 2. Now in practice set 6.1, the sixth sum onwards, we have different sums where we have to prove that is they have given a statement where we have to prove the LHS equal to RHS. For example, the first one, sin square theta upon cos theta plus cos theta equal to sec theta. And in these kind of sums, what we have to do is, we have to take any one side. Okay, here we will take the LHS. So if we take the LHS, that is we take only this part. Okay, sin square theta upon cos theta plus cos theta. And we try to solve with using different identities, different trigonometric ratios which are they're having relation between them. And we try to reach up to this RHS, sec theta. So this particular left hand side we have to solve and bring it to sec theta. And then we will mention that yes, hence we have proved that sin square theta upon cos theta plus cos theta is equal to sec theta. Okay. So as I mentioned that we are doing the third sum. Okay, the first and the second sum is for homework. I'll be straight away going to the third sum. Before that, I will just explain you all. I'll give you some hints to solve this first and the second sum. Now, if you see, look at the first sum. If you take the LHS part, here the denominator is cos theta. Here they don't have a denominator. So first thing we'll do is we will make the denominator same. So in order to make the denominator same, we have to bring cos theta in the denominator. So we have to multiply cos theta in the denominator and numerator of this term. When we multiply cos theta in the numerator and denominator, we get sin square theta plus cos square theta upon cos theta. Now sin square theta plus cos square theta is the identity we know is equal to 1. So what we will get is 1 upon cos theta, and 1 upon cos theta is nothing but sec theta. In this way we will get LHS equal to RHS. Even here we know the identity. Now this left hand side we have to bring to 1. Now we know this identity 1 plus tan square theta is equal to sec square theta. So that identity we will use here, and we will make this as sec square theta, and we will get cos square theta into sec square theta. So this particular bracket we will write as sec square theta, because 1 plus tan square theta is sec square theta. Now what we get is cos square theta into sec square theta. Sec square theta is 1 upon cos square theta when we learn the relation between them. So cos square theta into 1 upon cos square theta get cancelled and we get 1. So these two are very easy, and therefore I have given you all for homework. Now coming back to the third sum, we will take the LHS. So you'll see what is the LHS. LHS is this particular root. So basically when you get these type of sums where you get this 1 minus sin theta, 1 minus cos theta, what you do is try to multiply the numerator and denominator with the same type of expression here. Okay, now here top it is minus, down it is plus. So what we do is we multiply both up and down by 1 minus sin theta. The reason is 1 plus sin theta into 1 minus sin theta, we will get 1 square minus sin square theta. This is the expansion that we have studied. A plus b, a minus b is equal to a square minus b square. So the first step is to multiply the numerator and denominator by 1 minus sin theta. Usually when what is in the denominator, no, we are taking the opposite sign. So here down it is 1 plus sin theta, we are taking 1 minus sin theta, up and down. Okay, both the places we have to do. If we are doing in the denominator, we have to do in the numerator also. Now we will see what happens to this inside here, inside the root. 1 minus sin theta and 1 minus sin theta. These are the two same brackets. Therefore, we have written as whole square. It is just like a into a is equal to a square. So this into this is the square of the bracket. And 1 plus sin theta and 1 minus sin theta is 1 square minus sin square theta. This is which identity? A plus b and a minus b. It is a square minus b square, which we have used here. Okay, so even in reason you can write here, this is the identity what we have used. Now this you will not write, this identity you can write here. Now 1 minus sin square theta. Now 1 square minus sin square theta is cos square theta, because I will tell you here, see here, we know that sin square theta plus cos square theta is equal to 1. Okay, if I shift the sine square theta to the other side, I will get cos square theta is equal to 1 minus sine square theta. Or even sine square theta is equal to 1 minus cos square theta. So from this one identity, we have these two identities formed. One identity we knew, sine square theta plus cos square theta is 1. From this we can derive another 2. That is cos square theta is 1 minus sine square theta and sine square theta is 1 minus cos square theta. So we have used this here, that instead of cos square theta we have written 1 minus sine square theta. Sorry, 1 minus sine square theta we have used as cos square theta. This first one. Okay, now removing the square and square roots. So this square and this square root gets cancelled and this square and square root gets cancelled. Okay, so we get 1 minus sine theta upon cos theta. Okay, now we separate this. We write this as 1 upon cos minus sine upon cos. Can you see here? We have just split. The denominator is 1. I have split this. 1 upon cos theta is sec theta and sine theta upon cos theta is tan theta. Okay, see here. And therefore it is equal to RHS. RH is also same thing. So we write here which is LHS is equal to RHS. We had taken LHS and we have derived up to RHS. And therefore this final thing is very important to write again. Therefore whatever is the sum is proved. This we have proved that this is equal to this here. Okay. After the third sum, the fourth sum is for homework and we are doing the fifth sum. Now here cot theta plus tan theta is equal to cosec theta into sec theta. So here again we will take the LHS and we will prove the RHS it is equal to. So LHS is cot theta plus tan theta. Now we know what is cot and tan with respect to sine and cos. So cot theta is cos upon sine and tan theta is sine upon cos. Now we equalize the denominators. So we write it as, here we need to write which, I told you if you are using any identity, if you are using any trigonometric ratios, we need to write. Okay, so therefore I have written in the bracket since. This is a symbol for since. This is a symbol for therefore and this is a symbol for since. So since cot theta is cos theta upon sine theta and tan theta is sine upon cos theta, we have substitute. Now we make the denominators equal here. So sine theta into cos theta. So if we make the denominators equal, sine theta into cos theta, I have to multiply cos theta here and sine theta here. So cos square plus sine square. You will see here. Cos square theta plus sine square theta upon sine into cos. We know the identity cos square theta plus sine square theta is 1. Therefore 1 upon sine theta into cos theta. Now we split 1 upon sine theta into 1 upon cos theta. 1 upon sine theta is nothing but cosec theta. And 1 upon cos theta is nothing but sec theta. So we just write 1 upon sine theta is cosec theta, 1 upon cos theta is sec theta. And this is asked to prove. This is LHS we had taken and we have come up to this step. But this is equal to RHS. Therefore LHS is equal to RHS. And therefore what statement was given to us? This was a statement given to us. This is what we have proved. So this is very simple, children, but only thing is you should know which identities you have to use or which trigonometric ratios you have to use. Now we move to the sixth one. In the sixth one, 1 upon sec theta minus tan theta is equal to sec theta plus tan theta. So again we take the LHS, that is 1 upon sec theta minus tan theta. Now what we do is we multiply. As I told you, you see here, we multiply the numerator and denominator with the same thing but with the opposite side. What is in the denominator? Minus. So we are multiplying here with plus. Sec theta plus tan theta and sec theta plus tan theta, up and down. Okay. With that what happens? 1 multiplied by this bracket remains the same. And here this is in the form of A minus B, A plus B. So what is the identity? A square plus A square minus B square. Okay. So here this is A minus B, A plus B. So A square minus B square. So sec square theta minus tan square theta. Okay. Now sec square theta minus tan square theta, the answer is 1. How the answer is 1? If you see here, we know the identity 1 plus tan square theta is equal to sec square theta. Okay, if I shift the tan to the other side, it will become sec square theta minus tan square theta. Okay, if I shift this here, it becomes tan square theta minus sec square theta minus tan square theta equal to 1. So sec square theta minus tan square theta is 1 is substituted. And therefore we have got upon 1, denominator is 1, means we can write it as simple sec theta plus tan theta. Now this is LHS what we have got. Okay, we had taken the LHS and this what we have got. So which is equal to RHS. If LHS becomes equal to RHS, we can write 1 upon so and so is equal to this is proved. Okay. See here, this is proved. Okay. Now we move on to the 7th sum. Now in 7th sum there is a mistake in the textbook. Okay, so in the textbook the 7th sum is sec raised to 4 theta. Okay, if you see the textbook, in the 7th sum it is sec raised to 4 theta. You have to cancel and make it as sine raised to 4 theta. Okay, so this is a correction. It is not sec, it is sine. Rest everything is same. So sine raised to 4 theta minus cos raised to 4 theta is equal to 1 minus 2 cos square theta. So we are taking the LHS again. In LHS you will see sine raised to 4 theta minus cos raised to 4 theta. Now sine raised to 4 theta we can substitute as sine square the whole square. I'll show you, and here we are using the identities. What you have studied, indices, sorry. Here. So this sine raised to 4 theta can be written as sine square theta the whole square because you have studied in indices. Okay, 2 into 2 is 4. Okay, so if it is a raised to b the whole raised to c, it is a raised to bc. It's like that. Okay, so here we have not changed the sum, only this 4 we have split as 2 into 2. Okay, now sine, this is in the form of a square minus b square. Can you see here? Sine square theta the whole square minus cos square theta the whole square. So this is a square minus b square, which can be written as a plus b, a minus b. So sine square theta plus cos square theta, sine square theta minus cos square theta. You see here? I have also written here, as I told you, you need to mention whichever identities you are using. So here I have written here which identity we have used. Now sine square theta plus cos square theta is equal to 1. We know that. So this whole bracket becomes 1. And this is the other bracket. Okay. Now sine square theta minus cos square theta. This is what we have. 1 multiplied by same bracket is the same bracket. Now we have to bring sec theta plus tan theta here. Okay, so what we do is, we know this identity sine square theta plus cos square theta equal to 1. If I shift cos to the other side, what we get? Sine square theta is equal to 1 minus cos square theta. That is what we are doing here. Instead of sine, we are writing 1 minus cos square theta. I had, in the earlier sum also, I told you that from this one identity, we are getting 2 other identities. Okay, so this sine square theta is split as 1 minus cos square theta. Minus cos square. Now minus cos square theta minus cos square theta is minus 2 cos square theta. Okay. Now this is LHS. Yeah. So if you see in the sum, we have to make LHS equal to RHS. So RHS you will find 1 minus 2 cos square theta. So here we have derived this, which is equal to RHS. So LHS equal to RHS is proved. Now the 8th sum is for homework. We'll do the 9th sum. Now what is the 9th sum? They have given us something. They have given us tan theta plus 1 upon tan theta equal to 2. If you see here, tan theta plus 1 upon tan theta is 2. And we have to show that tan square theta plus 1 upon tan square theta equal to 2. So this is given, and from this we have to derive this. So here we will not take LHS, RHS because they have given us something, and that only we have to keep on developing so that we get this. Okay, so in that case first we will take what is given, and now what we'll do is we'll square on both the sides because what we have to find has square. So if you square, we have to take the whole square. So this whole square and 2 square. 2 square will become 4. Okay, now this bracket square means it is in the form of a plus b the whole square. So we have learned the expansion also. A plus b the whole square. We have studied the expansion as a square plus 2ab plus b square. That is what we are going to use here. Okay, so tan square theta plus 2 into tan theta into 1 upon tan theta plus 1 upon tan raised to 2 theta, that is square theta, equal to 4. 2 square is 4. Now here if you see this tan theta and tan theta gets cancelled because there is a multiplication sign here. There are brackets. Okay, we cannot cancel this tan theta and this tan theta because there is an addition sign in between. So finally what we get is, reason is written, the expansion. Finally we get is tan square theta plus 2 plus 1 upon tan square theta equal to 4. Okay, now this 2 we shift on the other side, it becomes 4 minus 2, which is 2. Okay, and now what we have got is tan square theta plus 1 upon tan square theta equal to 2. Okay, and if you see here, that is what is asked to show. Can you see here? Tan square theta plus 1 upon tan square theta is equal to 2. And that is what is asked to prove. Okay. If you want, you can write here, is proved. Clear? Okay, after 9th sum, this is the 10th sum. Again, this is come in the form where we have to prove the LHS equal to RHS. They have not given us anything that we can, like how 9th sum, they had given us, and from there we derived. So here, naturally, we have to take the left hand side first. So LHS. LHS is quite big. So we will take LHS, and that we have to come to this, sin A into cos A. So LHS is taken here. So there are a lot of things which we can use here now. Now tan A upon 1 plus tan square A the whole square plus cot A upon 1 plus cot square A the whole square. Now this is one identity here, that is sec square theta is equal to 1 minus tan square theta. Okay, and cosec square theta is equal to 1 plus cot square theta. Here I have not mentioned theta, I have mentioned A because in the sum also there is A. So you can write A if in the sum they have given A here. Otherwise you have to use theta only. Okay. Now here as we know that here if you see this sum, here we can use these two identities. So therefore we substitute this 1 plus tan square theta as equal to sec square theta and 1 plus cot square theta as cosec square theta. So these identities we have already studied. So now what we get is tan A upon sec square A the whole square plus cot A upon cosec square A the whole square. So this we multiply, as I said, indices you have studied. This 2 into 2 becomes 4. 2 into 2 becomes 4. So we have got basically what? Tan A upon sec raised to 4A plus cot A upon cosec raised to 4A. Now sec A is nothing but 1 plus cos and cosec is nothing but 1 plus 1 upon sine. So this sec A can be converted to 1 upon cos and cosec can be converted to 1 upon sine. But before that, see, this is a division. So they have put a division here, you can see, and then we have to convert this to multiplication. So here tan A divided by sec raised to 4A plus cot A divided by cosec raised to 4A. Now this division we convert to multiplication. Before that we will split. What we will do is tan A we know, this is tan, okay. We know tan A is sine upon cos, sec we know 1 upon cos, cot we know cos upon sine, and cosec we know 1 upon sine. So all these substitutions we will do first. That is substitution, not substitution, but using the formulas or using the trigo ratios. And all I have mentioned here down, whichever we have used, tan, we have used sec, we have used cot, we have used cosec. So everything is written. Okay. Now the division has to be converted to multiplication. When we convert the division to multiplication, this becomes the inverse. So it was 1 upon cos raised to 4. It has become cos raised to 4A upon 1. This was 1 upon sine raised to 4A. This has become sine raised to 4A upon 1. Okay. So if you are converting this, you have studied in the 6th standard. When we convert this division to multiplication, the second one becomes the multiplicative inverse. Now whatever we can cancel, here cos A and here cos A will be cancelled. So here will be cos 3A. One cos we will cancel. Okay, this cos and this we cancel, then remaining is 3A. this sign and this we cancel, then remaining is 3a. So what we get is sin a into cos raised to 3a plus cos a into sin raised to 3a. Now, we can take something common. That is, if you see here sin, here cos. So we will take common. Now we will take sin a only common because here only one sin is there, here 3 are there. We will take only cos a common because only 1 is here. Even if here 3a cos raised to 3a are there, here only one cos a is there. So we will take sin a and cos a out. So if we take sin a and cos a from here cos square a remains. And here sin a and cos a, then here sin square a remains. Now sin square and cos square a is 1. So that we put as 1. And therefore 1 into anything remains the same. So sin a into cos a. This is equal to RHS. Okay, and we have got LHS equal to RHS. Therefore what is asked is proof that this LHS equal to RHS is proved. Now after doing the 10th one, 11th one is for homework. And now we are going to study the 12th one. Again here LHS equal to RHS we have to do. Here LHS what is given is tan theta upon sec theta minus 1 is equal to tan theta plus sec theta plus 1 upon tan theta plus sec theta minus 1. Now looking at the sum, you will see that it will remind you something what you have studied in algebra. Okay, and that property what you have studied in algebra, we are going to use it over here. Okay, if you remember theorem on equal ratios. Okay, now theorem on, if you see here LHS is very small and RHS is very long. So in order, from just tan theta upon sec theta minus 1, we cannot derive this such a big equation over here. Okay, so algebraic expression here. Now, if you have to get this ratio, okay, so same as I told you that in algebra from a small term, how do you get a long algebraic expression? Even in geometry, from this one ratio, we can develop this long ratio here. So for that, first what identity we know about tan theta is 1 plus tan square theta equal to sec square theta. Okay, now in this, we want tan theta we want to substitute here. So we make it as tan square theta equal to sec square theta minus 1. Now tan theta is nothing but tan into tan. Okay, and sec square theta minus 1 is what? In the form of a square minus b square. Okay, which is a plus b and a minus b. Okay, so if you know this expansion, then we can use it over here. This is sec square theta. Now 1 means 1 square only. Okay, it is one and the same, 1 square and 1. So this is a square minus b square, and therefore we have split as a plus b, a minus b. Okay, and this tan square we have split as tan theta into tan theta. Okay, now what we do is we just shift this one tan theta here and this sec theta minus 1 here. Okay, you can see here. So tan theta upon sec theta minus 1 is equal to sec theta plus 1 upon tan theta. Okay, now why this shifting is done? Because say here, if you see what is asked and proved, sec theta minus 1 we wanted the denominator. Okay, and therefore this sec theta minus 1 I have shifted here. So this LHS is developed, but RHS we have not got. You will see RHS is very quite long ratio here. Now, therefore here, as I told you in your algebra, you have done how to expand that algebraic expression or that particular sum. So therefore the same thing we are going to use it here. That is, we are going to use by the theorem on equal ratios. Okay, and that is tan theta upon sec theta minus 1, which is equal to sec theta plus 1 upon tan theta, which is equal to, we will add this. Okay, so this plus this and this plus this here. Okay, and therefore we get tan theta plus sec theta plus 1 upon sec theta. Now we have just interchanged so that we reach up to this. So this is sec theta minus 1 plus tan theta, which is written as tan theta plus sec theta minus 1. We have just interchanged it, but you can see the signs are same. Tan theta plus sec theta minus 1. So that we reach to this, what is asked. Okay, and therefore this is proved. So here sometimes we have to use some properties of algebra. In geometry we have to use what we have studied in algebra. In algebra we have to use something what we have studied in geometry. So therefore these applications, how to use these applications you all should know, and it is very important. Okay. So this theorem on equal ratios we have used here. Okay. Thank you students, and have a nice day.